So good afternoon, Dr. Sanjeet Kumar Naik, sir, and welcome back participants for this third session of the day. The speaker for afternoon is Dr. Sanjeet Kumar Naik, sir. He's from Bennett University. Before inviting him, I would like to introduce him to the entire crowd. Dr. Sanjeet Kumar Naik received his BTech degree in Computer Science and Engineering from Biju Patnaik University of Technology, Odisha in 2010, and his MTech degree in Computer Science and Engineering from National Institute of Technology, Rourkela, India in 2013, and PhD degree in Computer Science and Engineering from Indian Institute of Technology, Patna in 2019. Currently, sir is working as an assistant professor in Department of Computer Science and Engineering at Bennett University, Times of India Group, India. Before that, sir was working as an assistant professor at Manipal University, Jaipur, and BITS Pilani, Hyderabad campus. His research interests include security and privacy issues in cloud data storage, security and privacy issues in IoT environment, image encryption using lightweight techniques, blind signature schemes, blockchain, and smart contracts. He has published many conferences indexed in core ranking and many journals of international repute, including IEEE Transactions, Elsewhere, and Springer. Besides, he serves as a reviewer of many IEEE transactions, journals of Elsewhere and Springer. He is a member of IEEE and ACN. During his PhD tenure, he was awarded from late Sushma Swaraj ji, the then Minister of External Affairs, Government of India, for achieving first position in technical poster competition during Global Conference on Cyberspace 2017, organized by Ministry of Electronics and Information Technology, Government of India. Also, Sir has received third prize for the Lance Stafford Larson Writing Award for graduate students from IEEE Computer Society in the year 2018. With this small introduction of Sir, I would like to invite Dr. Sanjeet Sir to please start his presentation.
Thank you, ma'am, for your kind words. I would like to thank AICT and Vaagdevi College of Engineering for giving me an opportunity to deliver a talk in the 1-week FDP program on cloud computing. So let me share my screen. I hope my screen is visible. Can you confirm it, ma'am?
Yeah, one moment, sir.
Yeah.
Yes, sir. It's
Okay.
visible, sir.
Okay. Okay. So good afternoon, all the participants. And I'm going to give a talk on information storage in cloud and accessing the data stored in cloud. So in this area, I will discuss some of the challenges and solutions. I will also show you some of the demo, how to store the data, how to access the data in Amazon EC2 instance, that I will show you. So prior to start my talk, I don't know the knowledge, as I don't know the knowledge of each and every participants. So I thought I will give a brief introduction of cryptography. So what is cryptography? It is like secure communication in an insecure channel. Okay, so all of you know this, right? So what we do, we generally send the data in the presence of an adversary. So what we do, the sender has some data, and the data he want to send to the receiver, that is recipient. Okay, so how he will send? He will send the data in an insecure channel. The channel is insecure. So how to send the data in the insecure channel? That is what we do in cryptography. Okay, and we have lot of adversary present in the who can see the channels. So those things are present. Then in cryptography, we have two kinds of cryptography. The first one is known as private key cryptography. So here what we do, we generally share a key between the sender and the receiver. Okay, so sender has a key, that is K, and the receiver has also the same key K. Here we don't bother how the key is shared between these two users. Okay, we don't bother about that. So what we do generally, the sender, what he will do, he will use the plain text, that is X, and he will use the key, that is K, to encrypt the data. And the encryption algorithm is known to public. Okay, so you can use AES algorithm. There are a lot of encryption algorithms available, so you can use that, so that we will get Y. Now what we will do, we will send this Y to the recipient, and recipient will use the same key, that is K, to get the data, that is X. Okay, so this is what we do in a private key cryptography. And here the main thing is that what is that? The key is shared between the sender and the receiver, that is this K. But in contrast to private key cryptography, in public key cryptography, we have two keys with respect to each and every participant. Okay, so the Bob, suppose, want to send some plain text, that is X, to Alice. So what Bob will do, Bob will maintain a public key ring. In this public key ring, he will keep the public key of all his friends. Okay, so like Joy, Mike, Alice, Ted, all these people are his friend with whom he may communicate in the future. So what he will do, from this ring, he will take the public key of Alice. Now he will use this public key, and he will encrypt the plain text X, and he will send it in the insecure channel. Now what will happen, the Alice will use her own private key to decrypt the message. Okay, so something is encrypted with the public key can be decrypted using the corresponding private key, and the private key is known to only Alice, whereas the public key is known to all the users. Okay, all the participants. So this is what is the what we do in public key cryptography. Okay, so this is again the same public key cryptography I have explained here, whatever I discussed in the last slide. So the same thing, we will use the public key and we will encrypt it, the message X, and we will send it to the destination B. Now destination will recover the message X using his private key. Okay, so with this introduction, with this preliminary discussion, I want to start my talk. And what I will do, I will start my talk with a brief introduction of the topic. I will motivate you what is the current challenges are available. Then we will discuss some solutions to those challenges, and I will show you some experimental results also. I will show you some demo also in this session. Okay, so let's start. Then what is this cloud storage? Okay, so as we are discussing cloud, so cloud storage stores different data. Okay, like we can store photos, we can store videos, we can store music, we can store contacts, files, a lot of things we can store. Why we are storing them? Because cloud storage help us in syncing the files with other participants. Okay, suppose I want to share some sharing the data. I want to share the data with somebody else. I want to share some photo with somebody else. Then I can use the cloud storage. Else, what we have to do? We have to take that in a pen drive and we have to send it to my friend. Then my friend will use that pen drive to get the data. Okay, it is time consuming. We can, within fraction of second, we can share. Then what we can do? We can sync the file. That means what? We can, at the same time, we can access the updated file in the mobile devices, in other devices where I have my account. Okay, so syncing means like the same data will be available across all the devices from where I will access the cloud storage. Okay, then it is cost saving. Yes, if we want to store a huge amount of data, then what we have to do? We have to purchase a lot of hardware, we have to maintain those hardware, then that is a costly affair. So what we will do? We will simply, by a click of a mouse, we can create a cloud storage. Okay, so that is what we say cost saving. Then it is easily accessible. Okay, the data can be easily accessible. So this is what cloud storage. Then generally this cloud storage, we store the data in an encrypted format. Okay, so that's what we will discuss. What are the challenges, how we will store the data in the cloud, those things we will discuss. So before that, I will just give you some motivation about the current scenario. So recently in the general meeting of Reliance, Mukesh Ambani ji, he told that data is the new oil. Okay, so that means what? Now everything is in terms of data. So who has the data, he is the richer person. Okay, so that is what he told. And as data is the new oil, then we have several questions related to data. What are those questions? The first question is how we will get the data. So how do we collect the data? Of course, we will use sensor devices. We will, from the sensor devices, we will collect the data. But here the challenge comes, how we can collect maximum data with minimum number of sensors. So this is an interesting research area many people are working. Then once we have collected the data, how we will send the data? Of course, we need proper networking. We need to access the channel. So how to efficiently access the wireless channel? How the sensor devices will send the data to the gateway so that we can do further processing. Then of course the sensor devices, they cannot store the data. Then who will manage those data? So for that we need cloud server. So cloud server is here, you see, it is like the main place where we store the data. Then once we have stored the data in the cloud, what we will do? Why we are storing the data? Because we want to learn from that data and want to do some analysis on over those data. Why we are doing the analysis? Because we want to predict something, or we want to come to some conclusion which will help the future data. Okay, so which will help us in doing or in providing some decisions. So that's why we are we are storing the data in the cloud. So again, all these are different techniques, and many people are focusing on all this area to improve the existing works. Then we told that we will share the data, we will store the data in the cloud. Then is there any concern of security of the data? Yes, of course. Why? Because we cannot share the sensitive data directly in the communication channel. So what we have to do, we have to encrypt the data. There comes the use of cryptography. So just to summarize this slide, to how we will collect the data, we will use the sensor. How we will send the data, we will use the networking protocols. Where we will store the data, we will store it in the cloud. How we will manage the data stored in the cloud, that is again a challenging. Then what we will do with the data, we will use the machine learning technique. How we will send the data, we will use some cryptographic techniques so that it will be encrypted. Okay, so these are the 5 questions related to data. Now we will move forward and we will discuss what is cloud storage. So cloud storage is a cloud computing model. Okay, though already I told you this is the formal definition I am giving you. It is like a cloud computing model, and data is stored in a remote server. This is very important. It is not stored in our server, and it is managed and operated by the cloud service provider. We don't manage the data. We give the access of the data to the cloud. So we are storing our data in the cloud. We are not storing in our local storage. And how do we access the data? We access the data using internet. Okay, so this is what we say cloud storage. Okay, so now let us see some implementation. Okay, how we will store the data in the cloud. So for that, what I will do, I will create an instance in Amazon EC2. So this is, once you will log into the Amazon EC2, Amazon management console, it will look like this. Then what you will do, you will click on EC2. Okay, so once you clicked on EC2, then what you will do, you have to create an instance. Okay, so that is, you go to launch instance icon. Then what you will do, now from here you have to create Amazon machine image. This is just like the operating system in our local system. Okay, so from here what I will do, I will choose Ubuntu server. Okay, this one I am selecting. This is a 64-bit operating system. So I will choose this. Then it will ask me for how many CPUs I need, what is the memory size. Okay, all these things it is asking. So as this is a free version, that is T2.micro, I will use this one. But if you want like to do more computations, then you can go for this one. Like see here, we have 96 CPUs and we have 384 GB of memory. Again, we have lot of options available, so you can use any one, and what for that you have to pay for the price. Okay, so I will, for the demo purpose, I am using this one. So that is T2.micro. Then what we will do, we will go to the click on next, that is configure detail. Here nothing to do. Okay, so just click on next, add storage. Here you can give how much storage you need. So I have provided 8. So by default it will come as 8. So if you want to increase, you can increase it. So then you click on next, then nothing to do here. Then here what I am doing, I am using a security group, like who can access the data. So I have created one security group, else you can create it from here, create a new security group. So what I will do, I will click on select an existing security group, and as I have selected it already, so I am going to select the same one. Then here you see the protocol that I am using here, that is TCP. All the TCP protocol can, if our connection is using TCP protocol, then we can access the data. What type of connection? I am allowing only SSH connection. Okay, and the port range is 22 and source is 0.0.0.0/0. That means what? Any address, from any address I can access. Here also you can restrict the address from where you want to access. So these things you can do. Then click on review and launch. Here it will show you what are the things that you have chosen just for a review purpose. Instance type I chose T2.micro, then this is the security group, all these things it will show. Then you will click on launch. So once you click on launch, it will ask for a choose an existing key pair or create a new key pair. Okay, so if it will create a public private key, okay, like what I discussed in the introduction of cryptography. So I told that there are two keys, one is public key and another one is private key. Okay, so here, so like what you will do, you will download the key pair here. One key you will store it in your system and the other one will be, okay, so other one will be stored in the AWS. So it is like the public key is stored in the AWS and the private key is stored with us. So as I have already downloaded one key, so I will use choose an existing key pair, and what I will do, I will use Sanjit demo. Okay, so this is the name I gave. So then I will click on acknowledge and I will click on launch instance. So we will wait for, I think, few seconds. We have to wait. So it will create the instance. Here you see it is showing pending. So once it is ready, then we can access. So here you can see, like now it has changed to running. That means what? Now the instance is running. Okay. And what is the IPv4 public address? So this one, that is EC2-35166. This one. This one is very important. We need to keep this address. Okay. Now let us see how we can access the data. Okay. So for this, what I am doing, I am pasting this here. Okay. Then this is my command prompt. Okay, so what I will do, first let me see where I am. So I am inside my desktop. Okay, so I am inside my desktop. Now what I will do, I will, and the file that I have downloaded, that is stored here. Okay, that Sanjit demo dot private key, that the .pem file is stored inside the desktop. Now what I will do, I will write this command. Okay, so what is the command? That is this one, ssh-i Sanjit demo.pem. This is my private key. Okay, then what I wrote, Ubuntu is the user of the system that I have created in the cloud, and at the rate, here I am giving the address. Okay, so here I have to change the address. This is the old one, so the new one I will paste it here, the same public address that we got from that I copied from here. See here, it is like last one is 223.112. So here you see 223.112, the same thing I am using. So then what you will do, you will press enter. So then it will ask, are you sure you want to connect to the cloud? Then you write yes. Okay, once you will write yes, then what will happen? It will get connected. Okay, so now I am inside my cloud system. Okay, so let us see what is present inside this. Nothing is there. Okay, so let me create a folder. Okay, so it is like mkdir Sanjeet. I have created. Now let us see whether the folder is created or not. Yes, the folder is present. That is Sanjeet folder. You can see. Let me go inside the folder. Okay, cd Sanjeet. So let me see what is there inside this folder. Nothing is there. So now what I will do, I will store the file inside the Sanjeev. So for that, what I have to do, the file is present in my local system. I want to store it into the cloud system. So how I will store? So what I will do, I will exit from this cloud, and from here I will send the file. Okay. So how I will send the file? So for that, this is the command. Okay. So what is the command? Sudo, we have to go to the super user mode, then secure copy of file. SCP is secure copy of file. Then what I am doing, I am using the same private key, that is sanjeetdemo.pem. Then what I did, hello1.c. This one is the file which I want to store into my cloud storage. Okay. Then what I am using, the same thing, that is ubuntu@ec2, this one, but this is the old one. I have to change it. Okay. So for that, what I will do, I will copy the same address, that is this address. Okay, so 223.112. Then what I will do, I will put a colon and tilde slash Sanjeev. Okay, so by what is the meaning of this, that if I am writing this, then I will be inside the root folder. If I will not write slash Sanjeev, that means it will not store the file inside the Sanjeev directory that I have created in my cloud storage. Okay, so let us press enter. So it will ask for the password. I have to give my system password. Okay, why it is asking? Because we are using the sudo command. So once you have given the password, then it will ask again whether you want to continue or not. We have to write yes. Okay, then it will show me that hello one has successfully transferred, that is 100% we have transferred. Okay, now let us go to the cloud and let us see whether the file has been stored or not. So I will go to the cloud again, and what I will do, I will see ls. Okay, see Sanjeev folder is there. Then I will go inside the Sanjeev directory, and what I will do, I will check inside this. See, hello one is there. So if you want to see hello one, you can see it like vi hello1.c. So we can see the file. Okay, this is the file that I stored in my local system. Now we have stored the same file in the cloud. Okay, so this is what I wrote. Okay, so this is how you will store the file in the cloud. And similarly, suppose you want to download the file from the cloud, for that also you can use. Okay, so for that also I wrote the command here, that is like here. Only thing is there, we have to give the source name first, that is ubuntu@ this one. Okay, and Sanjeev inside that hello1.c will be there, where it will be downloaded in my system users/desktop. Okay, so you can use. So like this, you can access the you can store the file and you can retrieve the file. Okay, so I hope this demo will be useful to you. So let me close my instance, because so that somebody else can use that cloud platform. So I will close the instance. So for this, we have to go to the action, then instance state, and from here what I have to do, I have to click on terminate instance. Okay, so like this, and it is successfully terminated. Okay, so then what I will do, I will go to my presentation. Okay, so this is how we will store the data in the cloud. And next, so what we did, we stored the data, and the same thing I want to display here, right? See, the data owner is storing some file in the cloud, and we are data users are accessing the files. Now what will happen? The same information is flowing in the network, and we are not encrypting the network. That means what will happen? The data, any external attacker, they can see the data, right? So they can see the data, and even the cloud storage server can see the data. Okay, that is, then what will happen? The privacy will get lost. Okay, so for that, what we will do, generally if you will ask any cryptographer, then they will suggest that you encrypt the data and you store it in the cloud. Okay, now we got the solution that we will encrypt the data. Now after encrypting the data, then we have to control the access, isn't it? Because who should access my data? So that is, I am storing my health record. Okay, so the whatever access I want to give to the doctor, the same access I will not give to the insurance provider, isn't it? So that's why we have to control the access of our resources. And how we will do that? So there are some access control mechanisms, so that we can really enforce the use of the data. So why we are doing this? So we want to prevent unauthorized use of a resources. Okay, so we want to prevent that one, and at the same time we want to prevent the use of a resource in an unauthorized manner, right? So that also we want to prevent. So using doctor's credential, the insurance provider should not get access. Okay, so that we will not allow. We have to ensure that the person who is accessing the data, that is doctor itself. Okay, so that those things we will for that we use access control mechanism, and for that we have access control policy. And for that, what we are doing, once the data owner has created the access control policy, that means who should view it, who should write, who should read the data, which data. So all those permissions the data owner will tell to the cloud service provider, and the cloud service provider will, what it will do, it will enforce that access control policy. So these are the things that need to be maintained by the cloud service provider once we have encrypted the data and we have stored it in the cloud. Now see, this access control mechanism works in this fashion. So we have an authorization database. So this database will check the ID and password, the authorization of user. Okay, so that is this authentication function. So from here user will give, and from here the data will be stored. I mean the password of this user will be stored here, then we will match it, and then we will give a access. Okay, so this is how the system resources are accessed. So this is just whatever I told in the previous slide, the same thing is presented in a diagram format. So this thing, then we are telling that we will encrypt the data and all these things we are telling, but for what the government is doing for keeping our data in private, so that less leak of our data will be possible. If you will search in the internet, you can find the lot of leak of the data happening. Okay, so leak of data is happening in Sony company, then IBM, so Dropbox, lot of companies, cloud storage provider. If we are storing the data, that is getting leaked. So for that, this European Union, they proposed in their parliament that general data protection regulation, and it was passed in May 25th May 2018. And why they passed this general data protection regulation? To harmonize data privacy laws across Europe. So what are the few articles I thought I will highlight you. So if you will go to article 7, 8, you can see the consent of the data owner is very much essential. Without the consent of the data owner, you cannot share the data with somebody else. Okay, suppose I am storing my data in Amazon. Now Amazon cannot store or cannot give access to anybody else without my written consent. So that is what written in this article 7. Then we have a data protection officer for that. So earlier no company was having a post called data protection officer. Now every company will have this one after this GDPR is been passed in European Union. So what this DPO will do, it will just ensure that whether the data of the client of that company, okay, so that is stored in a secure manner or not. Okay, then they told about the encryption. Then here this is the like they are telling that we will impose fine, okay, or we will impose the fine, and the company has to pay the penalty to the user if their data gets leaked. Okay, so then these are the three things, that is right of access, right to be informed, and right to be forgotten. So these are very important things. Like what is this right of access? So who should access my data? That is purely the decision of the data owner. Then right to be informed, if any leak happened, you cannot hide that. You have to inform to the concerned person that yes, your data has been leaked. Then the thing, yeah, some company, they due to their reputation, they thought that our reputation will be hampered or nobody will use our services. So what they do, they generally hide this information, but now onwards you have to inform to the user. Then what will happen? Right to be forgotten. So that is, suppose I have stored my data, and today and tomorrow if I will tell my service provider that okay, so and so data you please delete, then he has to delete that data. After 5 years, I should not get that, get somehow that my get the information that my data is stored in the cloud. Okay, so get deleted means it should be deleted. Okay, you cannot just erase the data memory. That is not the process. Okay, so that is what mentioned in right to be forgotten. If you will go to this link, you can get access about all these articles, and this is just like, if you can go through all these articles, you can know what they are doing, the European Union, what they are doing for protecting the data of their country's citizens. So in contrast to the European Union, we have in our country, that is Indian Personal Data Protection Bill. Okay, and this was passed in the Lok Sabha on December 11th, 2019, and this you can see the tweet by Ravi Shankar Prasad ji. He told, okay, so introduce the Personal Data Protection Bill in the Lok Sabha today. Here also the same things are available. Okay, so for the protection of the data of the Indian citizens. So see, like data protection officer, then penalties and compensation, right to be forgotten, right to correction and eraser, limitation on collection of personal data. So you can go to this link and you can see each and every individual chapters. Okay, whatever I mentioned in the last slide, the same thing is available in these links. You can go through this. Okay, so this is the Indian version of the data protection bill. Okay, so data protection officer has to be there. If I am saying the data has to be deleted, you have to delete the data. If I am saying that there are some penalties and compensation if the service provider will delete my data, so all these things are there. Okay, so this is the Indian version of data protection regulation. So as the data protection has come handy nowadays, so in his recent Independence Day speech, our Honorable Prime Minister, he told that India will soon have a new cyber security policy. Okay, here you see the Independence Day speech. He told that new cyber security policy will come, and lot of opportunities are there in this cyber security environment. Then in the same speech, he announced that National Digital Health Mission. Okay, so what will happen? The health record of the individuals will be stored in cloud storage. Okay, so then what will happen? Each and every individual person will have a health ID, and if you will show that health ID in some other city, then your data can be recovered. No need to do the same test again and again. Okay, so but here there are a lot of challenges. Okay, so how we will give the access control, how we will secure the data, so all these things are there. And that's why I see the insurance companies, pharmacies, telemedicine, hospitals, laboratories, everybody will access this data. Okay, so That's why this is a emerging area, and lot of people will start working now how we will provide a digital, how we will achieve a successful digital health mission in the coming years. Okay, so this is what I told till now in the introduction, that what I told, we will encrypt the data and we will store it in the cloud. And even if we are not encrypting the data, that means the cloud service provider has to facilitate all these things. So now if we have encrypted the data and we have stored it in the cloud, then what are the challenges? Okay, what challenge will come? So see here, what are the challenges? So what I told, how we will store the data, how we will access the data, those things I told. And also I mentioned that we will provide some access control mechanism also. Okay, so then after achieving all these things, we got the data stored inside the cloud, and that is in encrypted format. Now once the data is stored in encrypted format, then what are the challenges? So let us see one by one. So the first one is how we will operate on the encrypted data. Okay, so it is not the same thing if I am doing a function on plain text. It is not same as a performing the function on the ciphertext. Okay, so it is not same. How we will achieve that? So for that we have a beautiful technique in cryptography, that is homomorphic encryption. We can use that technique. This is if we want to operate on the encrypted data. Now suppose we have stored the data in encrypted format, then how we will search the data? So that is again another challenging problem. So for that, what we can use? We can use searchable encryption mechanism. Then we have another problem, that is data deduplication. Okay, so a lot of data we store generally. Okay, so if we are storing it in encrypted format, then it is very difficult to check whether the data are equal or not. So how we can facilitate that thing? How we can delete the duplicate data? Okay, so for that, what we have convergent encryption. Then at last, the cloud storage provider, then he can hide the data loss. Okay, if he will hide the information that data has lost, then what will happen? So we cannot know the data has been lost. So for that, we will have to check whether the data is lost or not. So for that, what we will use? We will use probable data possession technique. So these are the four current state of the art problems that is existing, and many people are working on these areas. So how to operate on the encrypted data, how to search the data, then what is how to do delete the duplicate data, how to check the integrity of the data. All these things are current state of the art research problems. And then what is happening, like I cannot discuss all the four data. So what I thought, I will discuss only this, how to perform operation on encrypted data. So let us proceed to this problem. So consider this scenario. Okay, so here there are three cars. Okay, these cars are internet connected cars, and they have this sensors, and there is a AWS IoT gateway is available, and we have a simple cloud storage service we are using. Okay, so this is full-fledged system. It has been implemented, I am assuming. Okay, then suppose SL is slippery level of the road. Now each and every car is sending the slippery level to the storage. Okay, and what this storage is doing, this storage is computing over this data, and it is sending a signal, okay, that the road is slippery, you please take care while driving. Okay, so the next incoming cars, it is saying, so this slippery level, that value, if it is greater than 0.5, so it got from 3 people, the data is greater than 0.5, then what it will do? Okay, 3 people have told that the road is slippery, let us send the alert message. Now suppose there is an attacker present in the network. Okay, and if they, whenever they are sending the text slippery level 0.8, then it is changing it to 0.3. Then here you see it got 0.6, and it is the attacker is changing it to 0.2. Then this is 0.3, so he is not changing this value. Okay, because he can see the data, it is traveling in the network. So what will happen? once it has sent the data and once it has modified, now the cloud will compute over the data, and what it will get? It will get there is road is not slippery, then it will send a green signal, and once it has sent the green signal, the two cars that is coming after some distance, then they will travel in full flow, full speed, and what will happen? Eventually they will collide, or due to the slippery there is a chance of accident. So what as a solution, what we can provide, we can send the data in an encrypted format. So what I will do, so this car, what it will do, this car will encrypt the data, and it will, that slippery level, it will send to the cloud storage server while encrypting the data. Similarly, the key is shared between the cloud storage server. Okay, so this green color key is used by this car, and the corresponding key is with the cloud. Okay, so the key is shared between the cloud and the corresponding car. Here I am assuming this solution. Then if it is encrypted, the attacker cannot see the data, and eventually what he will do, he cannot modify the data, right? So because he doesn't know whether it is greater than 0.5 or it is less than 0.5, then what will happen? Now the cloud storage server will compute over the encrypted data, and what it will do, it will send the alert message again. Now there is a less chance of accident. But what is the challenge here? So does it solve the problem? Of course it solved the problem to a little bit, but if the data that we are transferring, that is this which data we are transferring the slippery level. So this slippery level data, it is not that much crucial, because the data, if I will send the slippery level data, that is not my private data. So if I am sending it with a key which is known to the cloud storage server, then he can decrypt and he can see the data. That will not harmful for me. But if the cloud storage server can see the data, then if the data is sensitive data, then it will create a problem, isn't it? So if the data is a private data or it is a sensitive data, then what we should do? Of course, the solution that I told in the last slide, that will not work. We have to give a different solution. Now, what is the solution we want to give? So see here, each and every person is having a ECG sensors. Okay, so that is embedded in their body. So what they will do, they will send their ECG value, and that data is getting transferred to the digital format, and from the cloud storage server, doctor is accessing. See, if this kind of data, if I am transferring in the normal channel, then the adversary can see as well as cloud storage server can see. Okay, so what will happen if the adversary and cloud, they can see, then they can know what is the if my heart is having any problem or not. They can know this data, and this information I should not disclose with my enemy, because they can attack me. So that's why this, if I will follow the previous solution, then what will happen? My privacy of my data will get lost. Okay, so this is the problem. Now what I will do, I will give a solution. What is the solution? I will share the key with the doctor. Now see here, the data is shared, the key is shared with the doctor. So this person has shared the key with the doctor. So again, this person has shared a key with this doctor. So this person has shared the key with the doctor. So each and every individual person is having a key, and that key is shared with the doctor. So now what they will do, they will encrypt the data and they will send it to the cloud. If we will send the data in this fashion, then nobody can know the data. Okay, so only doctor can access the data. So that is a good solution. You can say that is a good solution. We will follow this solution. But if we will use this solution, then cloud cannot compute over the data. Okay, so how cloud can compute over the data if it need? So you can ask, sir, what is the need for compute over the data? What is the need? Why we will need? I will give you a scenario where we need to compute over the data. So see here, this is the same setting that I told you in the last slide. Now the same thing, the data is stored in the cloud. Now suppose there is an NGO who wants to ask this question: how many percentage of people with normal cardiac behavior in the age group 20 to 35 are available in this city? Okay, suppose the city I am talking about, Bhubaneswar. Okay, so if, or Hyderabad you take. Okay, so if any city, how it will happen? So how cloud can answer this? Here the privacy of each and every individual patient is not getting lost by answering this question. Okay, I am just asking overall idea, how many people are in a age group, how many people, so it can be a percentage. So now if the NGO is asking a question like this, then the cloud storage server should be able to answer this question, because this is a valid question. Now how the cloud storage server can answer this question? So then what we will tell, or what is the solution we can give? So this is a really challenging problem. If we want to answer such questions, at the same time we have to preserve the privacy of each and every individual user. Okay, now let us see. For this we have a beautiful technique in cryptography, and that is known as what? That is homomorphic encryption. Okay, so what is homomorphic encryption? The thing that I told you in the introduction. Okay, so the homomorphic encryption is the solution which we can use whenever we want to compute over the encrypted data. So suppose this is my data, that is A, and as we are telling that we will encrypt the data, so now E of A is stored inside the cloud storage server. Now what is the function that I want to apply over this E of A? That is F. Okay, so now F, I want to apply the function F on encrypted data A, and whenever I will decrypt that result, I should get F on A. Okay, so that means what? I should have a function which behaves like this. The cloud storage server, what it will do? It will compute a function over the encrypted data. Okay, and when it will return the result, then it should be same as this, that is function A. What I did? Encryption on function of A. And if I will decrypt this, what I will get? The encryption and decryption will get cancelled. I will get F of A. Okay, so my objective got fulfilled here. Okay, so what I am doing, I am sending the encrypted data, and the same time I am sending the function. Cloud is performing the function over the encrypted data. I am retrieving the result, then I am decrypting the that result, and I am getting the function over A. So this is what we got. This is how we will get the result. So the same thing I wrote here, this is known as homomorphic encryption. So what is it? Like encryption on the plain text, and if I am doing any operation over that, and then if I will decrypt, I will get back my operation on the plain text. Okay, so this is what homomorphic encryption is. Then I will just give an analogy, okay, so that you can clearly understand what is this homomorphic encryption is. Okay, suppose Alice, see what she wants to do. She wants to assemble the raw materials to form a jewelry. Okay, so these are the raw materials she has, and this is the person who will assemble all those materials and will form a jewelry. But Alice is worried about the theft. What is so that if I will give all these raw materials to this person, then he will prepare the jewelry and he will take away. So then what is the solution? She thought, what so I want to form the jewelry, Alice want to form the jewelry, at the same time she want to ensure that the person will not take her jewelry. So what she will do? she wants workers to process raw materials without having access. So then she is an intelligent woman, so she thought, I will use this technique. So this is a box, okay. So in this box there is a globes, okay. So this person cannot pass or will put his hand in this globe and he will form the jewelry, okay. So he cannot take the data, take the materials out of this box. Then Alice, what she will do, she will put all these materials and she will lock it. Then this globe box is locked, okay. So then what will happen, this worker will come, assemble all these raw materials and will form the jewelry and he will go back. Then Alice, she will open this lock and she will take the raw material, okay. Sorry, she will take the jewelry, okay. So this is what is an exact analogy of homomorphic encryption, okay. So I hope it is clear to all of you what is homomorphic encryption. Then what we will do, we will see some varieties of homomorphic encryption, okay. So we have additive homomorphic encryption, we have multiplicative homomorphic encryption, okay. What is additive homomorphic encryption? It is like if I am adding the if I am adding the encrypted M1 with encrypted M2, what I will get? I will get encrypted M1 plus M2. Okay, if I will decrypt it, I should get M1 plus M2. And what the cloud storage server did, he just added these two data. Okay, so this is what is additive homomorphic encryption. So encryption of X plus Y can be obtained by operating on encryption of X and encryption of Y with knowing the values of X and Y. Okay. Then what is multiplicative homomorphic encryption? So in contrast to additive homomorphic encryption, here what we will do, the cloud storage server will multiply these two data, that is M1 and M2, and then if I will decrypt the result, okay, then I will get M1 cross M2. Okay, so let us see some examples so that these two will be clear to us. So the RSA crypto system I am using here, okay, so this RSA crypto system, it is a an multiplicative homomorphic encryption, okay. So here what we will do, if I will encrypt, multiply the encrypted M1 with encrypted M2, then I will get encrypted M1 cross M2, and if I will decrypt this, I will get M1 cross M2, okay. So that's why we say it is a multiplicative homomorphic encryption, but this one is not additive homomorphic encryption, okay. So this one is not additive homomorphic encryption. We cannot achieve M1 plus M2 here.
Excuse me, sir.
Yeah.
Sorry for interrupting. Some of the participant is asking to repeat the topic once, sir, in the chat window.
Okay, okay. Which topic?
Hasanujaman, can you please tell which topic to be repeated?
I will check this.
Yes. Just now, hardly 3:25, 2 minutes
okay.
before.
Okay, okay. What are the, okay. What are the commands in Windows for the same? Okay, so I think Raj is asking about how we will store the data, storing the data in the cloud. So the same thing I think he is asking. So command is same and the SSH will work. Okay, so the same command you can use. It will not, there is not a big deal, and if you face any problem, you can write a email to me. I will reply you. Okay, so I have not tested it in Windows system, but the same command will work, I hope. Okay, because we are simply using SSH, it has nothing to do with the operating system that I am using. Just open the terminal and you can write the command, it will work. Okay, so yeah, repeat, sir, he wrote. Okay, so which one you want me to repeat? Okay, okay, Alice example. Okay, fine. Okay, any other thing? So this is Supriya told. Okay, okay, I will explain the same thing. Okay, so let me go back. Okay, so here, okay, so what I was discussing is like I have stored my data. Okay, I have stored my data and I have encrypted my data and I have stored it. Okay, so then, yes, that one na? Okay, okay, fine. Okay, okay, I will explain, no problem. I will explain. See, so it is like I am storing the encrypted data, then I want to perform a function over that encrypted data. Okay, then what I want, what this cloud server will do, he will simply apply the function over the encrypted data. Okay, he will simply apply the function over the encrypted data. We will see example, don't worry. So then if I am applying the function over the encrypted data, then I should get function of A. What is my objective? My objective is function applied over A. I want that information, but I am storing encrypted A and I am giving the function F. Now what will happen? So F of encryption of A should be equal to function of A and then encryption. And then if I will decrypt this one, I will get function of A, because encryption and decryption will get cancelled. Okay, so if some primitive is there who is doing this operation, who can perform this function, or which has like this kind of equality, then that can help us. That is what I want to tell. So how this feature is helping us, this feature is helping us using the homomorphic encryption. So here what I am doing, encrypting the plain text, then I am performing some operation over that, and then if I will decrypt that data, I should get operation over the plain text. Okay, this is what homomorphic encryption. Now let us see that example. Okay, so in this example, the same thing which I want to which I told previously in terms of data, the same thing here. What is the function? Function is to make a jewelry. Okay, what is my data? Data is these raw materials. Okay, and I want to give this data in a box. So that means what? In an encryption format. And this person, what his job? He will just apply a function, so that after applying function, the if I will open the box, then I will get what? I will get my jewelry. Okay, so let us see the process. So why Alice do not trust this person? Okay, she thinks that this person will take away the jewelry after forming the jewelry. So that's why what Alice will do, Alice will put all this data inside this box and she will put a lock. Okay, this is locked globe box. Now this person cannot take the data from this box. Okay, data means the raw materials. Okay, it cannot take all these raw materials. Then what will happen? This person will come here. Okay, and will take the what this person will do, this person will come here, he will put his hand inside this globe, he will make the jewelry. Okay, then he cannot take away the jewelry, because from this side he cannot take, because these are globed box. Okay, so these globes are there, so he cannot take the data or the jewelry. So now Alice will come here, he will she will open the lock and she will get the result. Okay, so she will get the result. So this is what I was discussing in Alice jewelry. Okay, I hope it is clear now. So if you can confirm. Okay, okay, so yes, okay, okay, thank you. So let me continue. The same thing, it is not a different thing, it is the same thing I am explaining using this Alice jewelry store. It is just an analogy. Okay, so that your concept of homomorphic encryption will be clear. So now the homomorphic encryption, I told it has two variants. Okay, the first one is additive homomorphic encryption and the next one is multiplicative homomorphic encryption. So in additive homomorphic encryption, what I am doing, I will add the encryption of M1 with encryption of M2. I will add these two value, and whenever I will add these two value, then what will I get? Encryption of M1 plus M2. Okay, this is what I will get. Then if it is multiplicative homomorphic encryption, then what will happen? If I will multiply both cipher text, then I should get encryption of M1 into M2. Okay, I will give you example, don't worry. So let us see. First, let us see the example of multiplicative homomorphic encryption. Okay. So what is RSA crypto system? This is a public key crypto system, and what we do, we generally encrypt the message like this: M1 to the power E mod n I am not writing here. Okay. So what I will do, I will multiply E of M1 with E of M2. Then what will happen? I will get, see here, M1 to the power E into M2 to the power of E. So I can take this M1 into M2 common and to the power E. So this M1 into M2 to the power E is in the same format, see here. So I can write it E of M1 cross M2. Okay, so this is the proof of RSA crypto system, that it is working, it will work like multiplicative homomorphic encryption. Okay. So that's why we say RSA is multiplicative homomorphic, but we cannot do additive homomorphic encryption using this. So let us see the example. Okay. So what I want to do, I want to find the area of this rectangle. Okay. So what is the value? That is width. I gave the value of width, that is 7. I gave the value of height, that is 3. Now what I want to do, I want to I want to find the area. Okay, so how I will do it? And at the same time, I don't want to give this 7 and 3 to this area solver. I don't want to tell that exact value of width and height. Okay, I don't want to tell that, but still I want to find what is the area. How we will do it? So we will use the same RSA encryption that I told. These are the security parameters. Okay, so this is the public key, this is the private key. Now what we will do, we will encrypt the height and width. Okay, so I encrypted 7, okay, to the power 23 mod 143, I got 2. So my ciphered width is 2. Similarly, I got ciphered height as 126. Now what I will do, I will send these two values, that is 2 and 126. See here, I am not sending the value 7 and 3. So the privacy didn't get lost here. Now this area solver, what it will do, it will simply multiply these two values and it will get 252. Then we will send this 252 to the area solver will send it to us. Then what we will do, we will decrypt the data. So once I will decrypt 252, I will get 21. So what is this 21? It is like 7 into 3, isn't it? This is the how we will find the area. So see here, at the same time I am calculating the area, and I am getting, I am achieving the privacy for height and width. Okay, so this is what multiplicative homomorphic encryption. I hope the example is clear. Let us see another crypto system, that is Payer crypto system. Okay, so Payer crypto system, it is an additive homomorphic encryption. Okay, so here I am not going to the detail, I will just show you here the ciphertext format. It is like G to the power M alpha into RA to the power N. Okay, so what will happen? So generally what I will do, G to the power M alpha plus M beta. Okay, so if I will multiply this CA and CB, what will happen? G is common, so M alpha plus M beta will come here into RA to the power N, and RB to the power N is there. So I can write it RA into RB to the power N mod N square. Now see here, isn't it in the same format of encryption of M alpha plus M beta? See, what is the ciphertext format? G to the power something, RA to the power N. Okay, so see here, MA, here RA is there, here also MA plus MB, here RA into RB. Okay, so this is how we will achieve additive homomorphic encryption. So this is a observation from Payer crypto system. So again, Payer crypto system is a additive homomorphic encryption. We cannot achieve multiplicative homomorphic encryption from Payer crypto system. Now let us see an example. So the similar kind of thing I am doing here. Here I have a perimeter solver. Okay, so this one can solve the perimeter. So what I have three sides. Okay, so side A, side B, and side C. Now what I will do, I will encrypt the three sides, that is 7, 3, and 8. So I will get these values 2028, 3468, 1499. There is no chance that you can guess this from you can guess the sides value of the sides from these values. Okay, so you cannot get it. We are sending, this is side A, side B, and this is side C. Sorry, this is A is written here. Okay, so now all these values are given to this perimeter solver. Then perimeter solver will do what? It will just multiply these values. Then we will send this value to this to us. Then what we will do? We will decrypt it, and we will get 18 upon decryption. What is this 18? It is like 7 plus 3 plus 8. Okay, so this is how we will achieve additive homomorphic encryption. Okay, so I hope it is clear, okay, to all of you. So let us move ahead. Okay, so like, does it solve the problem? So I told that we will encrypt height and width, we will encrypt side A, side B, side C. Okay, does it solve the problem? No. Why? Because I assume that my height is encrypted with a key and my width is also encrypted with the same key. All the three sides of the triangle are encrypted with the same key. This does not happen in the real life scenario. All the data owners should not share the key with each other. Okay, so if such is the case, then how we will solve the problem? Okay, so for that I want to give an analogy. Okay, so without analogy it is very difficult. Is there any real life problem existing? So I want to relate that. So that's why I gave this example. So see here, so I have there are three hospitals. Okay, that is Kalinga Hospital, Apollo Hospital, and this Institute of Medical Science and some hospitals. So these three hospitals are located in Bhubaneswar. So these three hospitals, what they thought that, okay, we will use cloud storage server, and they are storing the data in the cloud. So now all these persons, these hospitals, they are storing the data in the cloud. Now some NGO wants to ask this question: what is the total number of patients in the hospitals of Bhubaneswar are suffering from cancer, or they are suffering from AIDS, or they are suffering from corona? Okay, so all these things. So this is like somebody or some other disease, TB. Okay, so let us take those diseases. So these hospitals, they will not share with individual. Okay, so if all people will share the same key and they will encrypt their data, so some data is encrypted by Kalinga Hospital, that can be decrypted by Apollo if we will share the same key. Because these people will not share. Why they will not share? Because they are doing business over here. Okay, so they will not share the data. It will create a bad reputation for them if they will tell that I have for this heart disease, I have only 10 patients. Okay, so for operating this disease, I have only 20 patients. So that's why they will not tell. But they really want to help the government or the NGO in answering this question. Okay, so how cloud storage server can answer this question? Okay, and at the same time we want to preserve the privacy of individual hospitals. Okay, so how he will get it? So this is what is a big question, and this cloud service provider, how he can answer this. And what is our constraint here? Constraint is Kalinga Hospital, Apollo Hospital, and this Institute of Medical Science. they don't want to share the data. Okay, they don't want to share the key. Then now, if for a particular hospital, okay, there are several branches, like they have a branch in Odisha, they have a branch in Chennai, they have a branch in Delhi, so then they can use a same key. Okay, so that is not a big deal, but they are from different hospitals, so they will not share the key. So had it been the previous case, like same hospital, different branch in different city, then uh, the previous solution that I gave we can use, that is height and width we will encrypt with the same thing. We have additive homomorphic encryption. Simply I will just add all this data and I can give it to the NGO. That is not a big deal. But now if I have 3 hospitals and they don't want to share the key with each other, then how we will solve this problem? So let us see. So this I just wrote it in this format, that is encrypts. So the data owner 1, I mean data owner 1 means hospital 1 you take. Okay, so this is, he encrypted the value, that is how many patients suffering from cancer, let us suppose that value. So they will encrypt it and they will store it in cloud. And similarly other hospitals, so there are n hospitals. Okay, so each and every hospital will encrypt with the public key and they will store it in the cloud storage server. Okay, so then what will happen, the cloud storage server will go has the data. Now a cloud storage server, how he will perform function over the data. Okay, this is just a with notation I showed the same thing whatever I discussed logically in previous slide. Okay, so for this we how to perform computation on encrypted data when we have multiple keys, data has been encrypted with multiple keys. Okay, so how we will do that? So okay, so let us see how we will do that. So data owners, they do not trust each other. Okay, so that's why they will encrypt their data with their own key. Now how to do computation over the data that is stored in the cloud by multiple users? Okay, so what we will use, we will use proxy re-encryption technique. This is again a beautiful technique in cryptography we will use. So just to tell you all what is proxy re-encryption, it is like, so data is encrypted with the public key, data is encrypted with the public key of Alice. Okay, then this proxy, what it will do, this proxy will convert this data to a format so that Bob can decrypt the data. Okay, so here you see the data is encrypted with public key of A, we are converting it to data encrypted with public key of B. Now B can decrypt the data, isn't it, because it has been encrypted with public key of B. If we will encrypt the data with public key of B and if we will try to decrypt with private key of Bob, then it will not work. But if we can somehow we can convert it into this format, then we can decrypt. Okay, so this technique will help us. So the same thing written here, I am not going to discuss that. So for this, what we did, we proposed a new proxy encryption technique to solve this problem. And this is the proxy re-encryption technique. So Alice and Bob, they are generating a proxy, proxy server is generating a key using the key of Alice and Bob. Okay, then Alice is generating the ciphertext here, it is sending the ciphertext to the proxy, proxy is applying the re-encryption key and it is sending to Bob. Now Bob can decrypt the data. Okay, so I'm not going to the exact detail, mathematical detail, but it is happening. Okay, we proved this. So then this is and you may ask that, sir, this key generation, it is taking the private key of both Alice and Bob. Okay, so this, it see SK2 is the private key, SK1, then proxy can decrypt the data. What is what solution you gave? So I will tell you how we are generating the key, but proxy is not knowing the value what is the key of Bob and Alice. So for that, what we are doing, the proxy will generate a random number, it will send the random number to Bob. Now Bob, what it will do, it will divide with its private key and it will send to Alice. Okay, so R divided by XC2, mod n is there. These are modular operations. Okay, and then it will send to Alice. Then what Alice will do? Alice will multiply his Alice her public key with this, and she will send it to the proxy. Now proxy, what it will do? Proxy will just do a R inverse of this, then proxy will get the key. Okay, so this is the key. And more details of this scheme you can get it from this link. I will share the link with the organizer. This PPT I will share, you can get it from there. So this is what, okay, so this is how the proxy cannot know the key, but it can just convert the data encrypted in Alice key to data encrypted with Bob's key. Now let us see the same problem how we will solve using homomorphic and proxy re-encryption, a fusion of these two, how we will use and how we will solve this problem. So see here, like data owner 1 has encrypted all the data, the number, that is like how many number of patients with public key of 1, then this is public key of 2 and public key of n, all the data. Now we have a computation server. Okay, so what we are doing, we are just simply converting the data which is encrypted with data owner 1's key to data on with the computation server's key. Okay, who is doing this conversion? So the computation server. Okay, so all these computations we are doing, all these conversions we are doing. Then what we are doing, once it is converted, so now you see all the data are in the same key. Okay, so now we can do the homomorphic thing that we discussed earlier, because all the data are encrypted with the same key. So for this purpose we are converting to a computation server. Okay, so you can ask, sir, why this computation server? Who is this computation server? So see, like this data owner, they do not trust each other. Okay, but we can trust somebody. Like I cannot trust my friend, but we are trusting the banks, okay, for the transaction. So it is a similar kind of organization. Okay, so with whom each and every hospital will agree with this computation server, but they don't share the data with each and individual hospitals. Okay, and data owner I, suppose this is the NGO, it is requesting Y1 and Y2, then what will happen? We will encrypt, so the result will come in this format, isn't it? It will be encrypted with the public key of computation server. Then we have to reconvert it to the public key of the this person. Okay, so then we will send it to the data owner I. Okay, so this is the overall solution that if we will give a proper solution to this mechanism, then we can achieve our goal. But for this there are a few solutions, and we also gave a solution. So this Peter et al, what they did, they used the conversion of ciphertext encrypted with the individual data owner's key to ciphertext encrypted with the computation server's key. Okay, so what they used to do, the cloud storage server has to send to the computation server to perform this operation. Okay, now for this part, okay, so that is data part. Now the for result part also, the cloud storage server has to send to the computation server to achieve it. Now in 2014, this Wang et al, what they did, they somehow managed to do it here. That is, no need to send this data to the computation server, so that the communication cost is saved. But unfortunately for this one, they couldn't able to do it. Okay, so CSS has to send to computation server to perform this. So if n data owners are asking for the result, then n communication cost is there. But what we did, we did both the things at the cloud storage server level, so our communication cost is very less. Okay, so this is just a comparison. So see here, for the trans decryption phase, the computation cost, okay, the communication cost is very less, it is nil. But in other scheme it is order of n. Okay, so then we proved the security of the scheme. Okay, so that is, again, I'm not going to discuss. It is based on the composition theorem. Okay, so the security we discussed. Then this is the same thing, like how we analyze the security. We analyze the security using ideal world and real world. Okay, So this is again in the real world, we there is a trusted third party to whom if you will give the data, so he can compute. But here we don't have any trusted third party, so that's why we are using a two servers, and we are computing the computing over each and individual user's data. Okay, so this is the analogy that we gave in the proof. You can refer the paper. So this is the result you see. Okay, so if I will increase the number of data owners, the red one you see, these are R schemes. Okay, so if the number of addition is less than number of multiplication, then this is the computation, and if it is greater, then this is the comparison. Okay, so you can see here, as the number of data owners increase, the total computation time is very less as compared to the existing schemes. Okay, so and why we are achieving this? Because we reduce the communication cost. Okay, so then this is, we gave two scheme, right? So one is SEMKC plus and one is SEMKC star. So it is like whenever we have a function with number of addition and number of multiplication, then we can use this formula, that is if number of addition is greater than 5 times number of multiplication minus 3 divided by 2, then we can decide whether we will use the first version or the second version of the scheme. We gave two schemes. Okay, so here you can see the graph. The first one you see, suppose I have 60 number of multiplication and 10 number of addition, then what I should do? I should do this one star scheme. Okay, so because it is taking less time. Similarly, if you will see here, the plus one is taking less time. If I have 60 number of addition and I have 10 number of multiplication. Okay, so you can see this, refer this graph, and you can choose wisely which scheme you want to use. And this is just a comparison of the computation cost. And here also you can see we like the total computation cost is very less as compared to the other scheme. Here I took the costly cryptographic operations and I compared the time. Okay, like multiplication, modular exponentiation, modular pairing operation. So this is comparison of communication cost. This one is nil. Okay, so you can refer the paper for this. Okay, so with this I conclude my talk. Okay, so what I told, that we need to protect our data using encryption. Okay, so we need to store our data in the cloud. We need to give the access control to the to our data in the cloud. Then I told, once we have encrypted the data, then we have several issues coming up. Okay, and what are those issues? Like how to perform computation over the data, how to search over the data, how to delete duplicate data, how to check the integrity of the data. All these things comes into picture. Okay, so here in this talk I discussed about like how to securely compute over the data, encrypted data. So in future, if time permits, then we can discuss other issues also. So here I want to give some research directions before I stop my talk. So the cloud server is returning the computed result, right? So how we can verify the result, whether it is giving the correct result or not? So we need to verify the result, isn't it? Otherwise he may cheat. So suppose earlier I asked a question, so for that he has computed the result. Now also he is sending the same result to me, okay, without any computation. So how I will ensure that? So for that, what I am currently working on, so I am currently working how blockchain can help in answering this question. Okay, so what is blockchain? It is a decentralized information sharing platform. Okay, it is a decentralized, there is no central server of blockchain, and here it enable multiple parties who do not trust each other to collaborate in decision making. Okay, so I want to make a decision, and at the same time the people, the hospitals, they do not want to trust each other, and I want to verify the result. How I can do that? So I am currently working on this now, how blockchain technology can help me. So again, this blockchain has a lot of use cases. Okay, so in lot of areas you can use, like see supply chain, healthcare, then real estate, energy, waste management. Okay, so national security, music, enterprise, railway, energy, lot of sections are there. In mobile payment, everywhere we can use this blockchain technology. Okay, so you can work on these area, how these areas can solve this problem. Okay, so then This is another directions I thought I will tell you. So that is data corruption in cloud. Okay, suppose data owner have stored the data like M1, M2, M3, M4, and M5, and then these are some external attackers. They have modified M1 and M5, and they have changed it to M1 dash M15, and some internal attackers are there who are present in the cloud. So internal attacker 2 has deleted M4. Okay, so now whenever data user will access the data, so how he will ensure that the data are correct? Okay, so for this, what are the solutions you want to give? So this is again another challenging problem. Maybe some other day we will talk on this. Okay, so then again, this is a open challenge available. So those who are interested in cryptography, they can go for this. Okay, so this is by Ministry of Electronics and Information Technology. So you can go to this website and you can log into this, and this is a 1 year challenge. Okay, so you can try with registration. Okay, so it is starting from first week of September. So open to all the disciplines of students, employed, who are researchers, okay, startups. So again, they are giving a money for 7.5 lakh if your lightweight cipher got award. Then we have lot of lightweight ciphers like present, Simon, rectangle. Then we have stream ciphers like trivium, grain family cipher. So then again, like we have all these ciphers, still people want to get some lightweight cipher design. So that's why they gave a challenge and they want more lighter cipher. Okay, so if you are interested, you can go for this open challenge. Okay, so these are some of the selected references, and thank you all. If you have any questions, then I will be happy to answer. Over to you, ma'am.
Thank you so much, sir. I request the participants to please unmute and have a discussion with sir regarding any queries. If anybody would like to share your views, give your feedback, or ask your queries, you can please unmute and we can have a conversation with sir. So I think the session was more than clearly understandable. So there are no queries and nobody is like unmuting to speak. So Sanjit Naik, sir, thank you so much for accepting our invitation, sharing your profound knowledge with all our participants, especially the research orientation which you have given. Perhaps it will help all the research scholars who have registered here and many of them who are doing their further research in cloud computing. Thank you so much for all the things. Sir, some of the participants were asking if you can share the PPTs, sir.
Sure, I will share, no problem.
Okay, you can just mail me. Yeah, please, sir. Yeah. I will share with my participants.
Yes.
That was so kind of you. Thank you so much, sir.
So the demo that somebody was asking, no, like that demo that I showed, yeah, that one. So if I am writing my email ID here, so if so just try the same thing. Okay, so this is my email ID. Okay, so if you face any problem, just write an email. That will work in Windows system. Okay, not a big issue, so you can work. Okay, thank you, ma'am. Thank you for.
And I want to inform all the participants that whichever session is being recorded, by the end of the day or tomorrow morning, it will be posted publicly in YouTube and the links will be shared to you in WhatsApp. So your recording session will be posted in YouTube. Once it's posted, I'll share the link to you also, sir.
Yes. Okay. Thank you.
Thank you so much, sir. Have a good evening.
Yeah, thank you.
I thank all the participants for making the day one of this FDP such a success with not putting down the strength and always with the same energy. Hope the rest 4 days also will be so energetic. Thank you to each and every participant who attended all the sessions for today. Thank you so much.